Today we're going to be working on Module 1, Lesson 3, Addition and Subtraction of Signed Numbers. So like I said, this packet you're going to learn a bunch of different ways. You're going to learn with the chips that we start with, then you're going to learn with the number line, then you're going to learn the rules. So you'll have all different ways to help you remember these, not just one way. So we're going to begin with adding integers with the same sign. So integers are just positive and negative whole numbers. 0, plus and minus 1, plus and minus 2, plus and minus 3. That's what integers are. No fractions, just positive and negative whole numbers. So this first one is 5 plus 3, an easy one that you could do with, without chips, but it just shows you how it works. So we have 5 positive chips added to 3 positive chips. Nothing cancels because they're not opposites. So we end up with 8 positive chips. And it works the same when we're doing subtraction. Or excuse me, sorry about that. When we're adding with negative numbers. And I really don't like how they made this packet. Our district got together and each of the schools picked their own units to do. I can't remember which school did this, but whenever you have 2 signs side by side, the rule is you're supposed to have parentheses around the second. So I noticed that throughout this packet, and it drives me nuts because you're really not supposed to write it like that. But oh well. Okay, so this one, it's 5 negative chips plus 3 negative chips. Nothing cancels, they're all negatives, so I end up with a total of 8 negative chips. So when nothing cancels, you just add them all together, that's it. So the rule that we're going to learn about this is when the signs are the same, both positive here, we add and keep the sign. When the signs are the same, both negative here, we add and keep the sign. So same, add, keep the sign. That's all you have to remember. Same, add, keep the sign. So using the integer chips, represent the following numbers and their combined amount. Using the table to show how you did this, plus or Y for yellow, minus or R for the negative chips. So this is a positive 7 and a positive 8. So our first number is 7 positive chips. Our second number is 8 positive chips. And we see that there is nothing to cancel, no opposites. Yesterday or on our last lesson, we learned that a positive chip cancels with a negative chip. They undo each other. None of that here. So all of these are going to be our combined amount. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 positive chips. So rather than draw 15, I'm just going to put 15 positive chips. Nothing cancels, so you just combine them all together. The math equation would look like 7 plus 8 equals 15. So something you already know, but why we're doing the easy ones is because you'll see that when they're negative, it's the same thing. Negative 7 plus negative 8 equals negative 15. So it doesn't matter whether they're both positive or both negative. The rules are the same. When the signs are the same, add and keep the sign. Okay, so let's move on to some new ones. So we'll do one more together and then you guys can try the next 2 before we move on to the next page, just to give you some practice. So this one has and does everybody know the word sum? Because you do have to know those on your test. Sum means add, difference means subtract, let's go ahead and write them here just while we're talking about it, and then that way you can highlight it and to make sure to study this page. So sum means add, difference means subtract. And I remember there was a guy this semester in my 081 class, it was in person, and he got everything right on the entire test, but every time he saw difference, he multiplied. So yeah, that made him have a B on the test instead of an A, but that's why you need to know these, because throughout the semester you are going to be using these words. And then product means multiply. And once we start algebra, we use multiply with a dot. So since your next class is pre-algebra after this, I would recommend trying to practice with the dot. It's not wrong if you use an X, but I would just start practicing with that. And then last but not least is quotient, which means divide. So I would bubble that, I would highlight that so that you know those keywords, because you'll see them several times on this test and on every test after that in the future. So let's do a big bubble here so we have it. Okay, so this one says find the sum by combining them into one group. So this one we have -3, so 3 negatives, and a -7. 1, 2, 3, 4, 5, 6, 7. Again, we don't have anything that cancels because they're all the same sign. So the rule is when they're all the same, you just add them together and that's your total. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 negative chips. So the math equation for that, since it says sum, it's going to be plus. So it would be -3 plus -7 gives us -10. So -3 plus -7. And again, notice how I put the second sign and its number in parentheses like you're supposed to. Did I give it? Yeah, I wanted to make sure I gave an answer on that last one. Okay, next two are yours, so go ahead and stop the video, draw your pictures, get your answer, and then start it back up so you can check. So we're back to positives here. So we have 5 positives, and then a +6, and this says sum, so that means plus again. So +5, +6, and the sum is going to be all of those together because nothing cancels again. So that leaves us 5, 6, 7, 8, 9, 10, 11 positive chips. So our addition problem would be 5 plus 6 equals 11. I'm sure all of you got that right. Okay, now we're going to do the same but with negatives. So I'm sure you guys already got the answer to this. So again, it's sum, so I know it's going to be an addition problem. And we have -5, so 1, 2, 3, 4, 5, and then we have -6. Again, nothing cancels, no opposites, so we're going to have a total of 6, 7, 8, 9, 10, 11 negative chips. So that would be -5 plus, because it says sum, -6, which will give us -11. So when the signs are the same, which they are, both negative, we add and keep the sign. And I always like to think when I'm doing adding and subtracting about money. If I have -5 in my checking account and I go out and spend 6 more on my debit card, now I'm at negative 11. Likewise, if I have $5 in my checking account and I put a deposit in of 6 more, now I have 11. That's how I remember the rules. I don't think about chips too much. I don't think about the number lines. I think about money in my checking account. And I grew up balancing a checkbook, unlike probably most of you did. So we got a lot of practice with the positives and the negatives, just by balancing our checkbook. But that's how I think of it. So negative means you're spending more, positive means you're depositing money in. So that's a good way to remember addition and subtraction without remembering any rules. Okay, so determine the following sums. Imagine in your mind's eye what the set of chips would look like. If you want to draw the plus and minuses to help you, go for it. So sum of 4 and 2, I think everybody can do that one without any chips. Sum means plus, and 4 plus 2, I think we all know, is 6. And then same thing here. And if you want to 1, 2, 3, 4, and then 1, 2. So what is the sum of negative 4 and negative 2? Well, nothing cancels. So negative 4 plus negative 2 will give me a total of 6 negative chips, which is negative 6. So same rules. Doesn't matter whether they're both positive or both negative. When the signs are the same, we add and keep the sign. And then same thing with the others. 8 plus 9 is 17. So if I have negative 8 chips and 9 more negative chips, I'm going to have 17 negative chips. 2 negative chips plus 5 more negative chips leaves me with 7 negative chips. 2 positive chips plus 5 positive chips gives me a total of 7 positive chips. So if you were to describe, we don't need to do this, but let's look at number 10. If you were to describe a rule for what we did above, how would you say it? So like I said, I give my students 2 rules for addition and subtraction. You haven't learned the second one yet, but I tell them when they go into their tests, just like in your head, be chanting. Same, add, different, subtract, keep the sign of the larger. That's how I tell them. That's all you need to know about addition and subtraction. Same, add, different, subtract, always keep the sign of the larger. So on this one it would be same signs, add, and keep the sign. So if they're both positive, keep the answer positive. If they're both negative, keep the answer negative. So add and keep the sign. And that's the same thing as keeping the sign of the larger, because they're the same sign. So when you keep the sign of the larger, that's the same thing as keeping the sign. So same signs, add, and keep the sign. And like I said, that is something I would definitely highlight along with that, what we did on the other page. So when the signs are the same, add and keep the sign. Okay, now we're going to do the next scenario. What do we do when the signs are different? And this one kind of blows students' minds at first, because they're like, well, I don't understand how when they're different you subtract. It says add. Well, add doesn't necessarily mean add when you have sign numbers. So, and you can see in this example, and again they forgot the parentheses, kind of drives me crazy. So I have 5 positive chips, I have 3 negative chips, and you don't need to do this second thing. You can just go here and go, okay, this one cancels with that one, this one cancels with that one, this one cancels with that one, because now they are opposite signs. So what do I have left? 2 positive chips. So positive 2 is my answer. So cancel opposites, whatever left is your answer. So that means 5 plus -3 is 2. So 5 plus -3 is 2. And we're going to learn the rule for this is when the signs are different, subtract, keep the sign of the larger. So 5 minus 3 is 2. Which number is larger? 5. So keep that sign. And again, think of money. You have $5 in your checking account and you just went out and spent 3. So now you have $2 in your checking account. Money is so helpful when you're doing these. Okay, now we're going to do the other scenario. Now there's 5 negatives, 3 positives. So again, we do our canceling. And I'm left with 2 negative chips. So what does that mean? -5 plus 3 is -2. So we think of money. Oh man, I'm overdrawn. I have -5 in my checking account. So I go to the bank and I put in $3. So what's my new balance? -2. All about money. We never forget money. That's why I love the money rules for addition and subtraction, because we deal with it every day. So we never forget it. But you can see both of these fit the rule. When the signs are different, you subtract, keep the sign of the larger. When the signs are different, a negative and a positive, you subtract. 5 minus 3 is 2, and you keep the sign of the larger. The larger number in this case is negative. So same, add, different, subtract. Always keep the sign of the larger. Okay, so let's do some practice here. I think we have 4 again. Yep, so we'll do 2 and then you can do 2. So we have +7. So 1, 2, 3, 4, 5, 6, 7. And it says sum. So again, we're going to have an addition sign between the two numbers. And then -3. So we already know our equation's going to be 7 plus -3. And now we're going to find the answer. So this says to add the two, +7, -3. So then we do gone, 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 gone. What's left? 1, 2, 3, 4 positive chips. So the answer is +4. And then I check it. I check it with money. I check it with the rules. If I have $7 and I spend 3, do I have 4 left? Yes. If the signs are different, I subtract and keep the sign of the larger. There we go. I've just verified the answers 3 different ways, with chips, with money, with rules. You do that, and I will tell you every semester my very best students are the ones that go back and check their work and do a different method. Or cover up the page where they did the work the first time, do it the second time, see if they get the same answer. So students that go back and check their work or do it multiple ways are always the ones that do best in my class. Okay, next page. So let's do one more together and then you guys can stop the video and try on your own. Okay, +3. So we have 3 positives. Again, we're adding. Keep my eye on the prize there. So we have 3 positives. So we know it's going to be 3 plus something. And a -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 plus negative 9. So we go to our canceling because opposites undo each other. Gone, gone, gone. What do I have left? 1, 2, 3, 4, 5, 6 negatives. So that means my answer, whoops, I should have put, so that means my answer is -6. Then I check it with money. If I have $3 in my account and I use my debit card and go out and spend 9, yep, my balance is going to be -6. And then I use the rules. If the signs are different, you subtract. 9 minus 3 is 6. Keep the sign of the larger negative. And if students just stopped to do that, they would miss so many fewer problems, because sign errors are the #1 biggest problem in this section. Like, students will put 6. Had they checked it a different way, they would have caught that they lost the negative. Okay, go ahead and do the next 2 problems. Turn off your video and turn it back on when you're done, and then you can check your work. Okay, this first one, we have 3 negatives and 8 positives. You'll get so you can start canceling in your head and even do these in your head, because you'll take 3 of the positives away and you'll go, oh, I have 5 positives now. It's cool because this is such a visual method. It really makes students learn the rules well. So gone, gone, gone. What do I have left? 1, 2, 3, 4, 5 positive chips. And again, it's adding. So this would be -3 added to +8, and we see the answer's 5. When the signs are different, subtract. Keep the sign of the larger. Yep, 8 minus 3 is 5. And keep the sign of the larger plus. Last one, another sum. So I know my equation is going to be something plus. So it looks like represent -8 and +2 in their sum. So -8 and a +2. So 8 negatives and 2 positives. Gone, 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 and that leaves me 1, 2, 3, 4, 5, 6 negatives. So that means my answer is -6. So I hope you guys did okay on those. Okay, so next we're going to practice another set of practicing, then we're going to go to the number lines. So this is what I tell students to do. One of the things, I studied psychology a lot in college, and psychology of education, one of the things that they recommend when you take a test, probably the #1 most recommended, is when you start your test, you know, your paper's blank, you've shown it to the camera. First thing you do once you hit start on Alex is do a data dump. Anything you can remember, dump it on the top of your test. So on this section, I would go same, add, different, subtract, always keep the sign of the larger. So that's just kind of a little shorthand for the addition and subtraction rules. And it doesn't just work in addition, it also works in subtraction. So you'll have a lot of problems with adding and subtracting sign numbers for the rest of your life. So that's all you have to remember. Same, add, different, subtract. Keep the sign of the larger. So I see that we're adding They are definitely different signs, a positive 9, a negative 4. So I subtract and keep the sign of the larger. 9 minus 4 is 5. The larger number's plus. And you all know that we don't need to put a plus sign with the 5, right? I don't know if Alex would count it wrong. They might give you a little note and say, or an alternate answer is 5. And sum of 4 and negative 9, 4 plus negative 9. Again, the signs are different. One's positive, one's negative, so I subtract. 9 minus 4 is 5, and I keep the sign of the larger. 9's larger, so that means it's negative 5. And then after you apply the rules, do the money thing. If you have $4 and you go out and spend 9, guess what? Your balance in your bank account is now negative 5. So apply the rules, go back and check another way. So negative 10 plus 2, a negative and a positive tells me to subtract. 10 minus 2 is 8. Keep the sign of the larger, and that's the step students don't always do. They decide to add or subtract, and then they forget to keep the sign of the larger. So again, different signs, a positive 10, a negative 2, so subtract. This time the sign of the larger is plus, so no sign needed. And next we have a positive 8, a negative 9. The signs are different, so we subtract. 9 minus 8 is 1. Keep the sign of the larger. Positive and a negative, the signs are different, so subtract. Keep the sign of the larger. So for our rule down here, we can just write when the signs are different, meaning one's positive and one's negative, subtract and keep the sign of the larger absolute value number. And the reason when we're formally saying the rule, we have to say that, you don't have to say it to yourself, is because 9 really isn't the larger number here. Negative 9 is smaller than 4. So we look at the absolute value. We're just looking at 4 and at 9. 9's larger, so we keep the sign of the larger. So if you were like taking a test and somebody asked you to write the rule, you would have to write absolute value, but you don't need to say it in your head. Just say, signs different, subtract, keep the sign of the larger. Okay, so that's the rule. Like I said, it works for addition and subtraction. So that's pretty handy. Okay, so let's do one more page. We got a couple minutes left till we hit 30, and then we'll pick up in the next video. So this is yet another way, and probably if I had my pick of ways, I love this way. But could you imagine drawing a number line every time you wanted to add or subtract? That would take forever. You probably wouldn't get your test done, right? So although it is an awesome visual, it's just a little bit time consuming to use on every problem. What if you have 365 plus 589? Well, drawing that in a number line would be tough, but when the numbers are small, it's pretty easy. So this one says, so we always start at 0. It says go up 5 and then go up 3 more. Where do you end? At 8. This one says start at 0, go back 5 and go back 3 more. where do you end? -8. So to me, that is super, super visual, like the chips. I love it because I can picture it in my head without even drawing it. I'm adding 5 and then I'm adding 3 more. I'm going back 5 and then I'm going back 3 more. That puts me at -8. And it works when the signs are different as well. So this one says start at 0 and go up 5. From 5, go back 3. And where do you land when you go back 3? At 2. So you start at 0, go up 5 from that position, then you go back 1, 2, 3, and you land at 2. And then same thing with this one. Start at 0, go back 5, and then you go up 3. Where do you land? At -2. So if you had a number line in front of you, oh man, this is such an awesome way to do it. But like I said, of all the methods, although I think it's one of the best and most visual, it's the least practical when you're taking a test. But what a lot of students say is, I don't really draw it, but I can picture it in my head what it looks like, and I can get the answer that way. So it's a cool method as well. Okay, so let's do a couple and then we'll start a new video next. So this one says go up 7 and then go up 3 more. Where do I stop? At 10. So 7 plus, whoops, it asked me to write it here. So 7 plus 3 equals 10, which we all know, right? And then the last one, this tells me to start at 0 and go up 7. So start at 0, go up 7, and then it says to go back 3. So 1, 2, 3, and where do I end? At 4. So 7 plus -3, when the signs are different, subtract, keep the sign of the larger. So that makes sense that our answer would be 4. Okay, we'll start on the next page in the new video. See you in a few.